Now let us look at the next problem. If a simple pendulum has significant amplitude, that is up to a factor of 1 by E of original, only in the period between t equal to 0 to t equal to tau seconds, then tau may be called the average life of the pendulum. When the spherical bob of pendulum suffers a retardation due to viscous drag proportional to its velocity, with b as the constant of proportionality, the average life time of the pendulum is, okay, we are assuming that damping is small. Okay, now let us understand. Now let us say this pendulum is there, which is suspended from the ceiling, and it is kept in an atmosphere or surrounding wherein this bob experiences viscous drag. Okay, now because of viscous drag there is damping of motion. Okay, now let us say at particular instant of time when the bob is moving towards the mean position with a speed v, this speed v will be written as omega L, where omega is the instantaneous velocity, which can be written as minus d theta by dt times L. Okay, so v is equal to minus L d theta by dt. Okay, this is one aspect. Second is, it is given that the viscous force is directly proportional to the retardation. The retardation due to viscous drag is given as directly proportional to velocity, where constant of proportionality is b. So retarding force A R will be equal to bv. Okay, that is proportional to v, so AR is equal to bv. So viscous force will be given by mass into acceleration, that is mbv. Now we know that this force is acting against the motion. If velocity is in this direction, viscous force would be in the opposite direction, and the component of weight, that is mg, is mg sin theta in this direction. So mg sin theta is trying to restore the bob to its original position, and viscous drag is opposing that motion in this particular diagram. So this restoring torque tau, which can be written as I into alpha, where alpha is d square theta by dt and I is moment of inertia, which in this case is m L square. Okay, mass of the bob, and L is the length of the suspended string. So ml square is moment of inertia, and alpha can be written as d square theta by dt square. This torque, which is restoring in nature, is due to the moment of force of mg sin theta, length is L, and also the viscous drag, which is acting in the opposite direction, which is m bv. Now this can be written as minus mg. If we assume that the value of theta is very small, then sin theta can be written as theta. So this expression will become minus mgl theta, and if we substitute the value of v as minus l d theta by dt, then we will have minus mbl d theta by dt. Now this torque can be replaced by or substituted by this expression, m L square d square theta by dt square. Okay, now in this expression m cancels out, and here this force we have not multiplied with the L, so this will become L square. Now we will get d square theta by dt square equal to minus G by L theta minus B d theta by dt. Okay, which can be further written into as d square theta by dt square plus b times d theta by dt plus g by L theta equal to 0. Now this differential equation is of a special kind wherein the solution of theta is given by theta naught e to the power minus b by 2 t sine of omega t plus phi. Okay, now just try to understand this expression. This expression is equivalent to the amplitude, but due to the damping this amplitude is reducing exponentially. Okay, wherein the sine omega t plus phi, they are of the generic terms, that is omega is angular speed of the simple harmonic motion that is being undertaken by the bob or the simple pendulum, and phi is the initial phase difference. Okay, so this equation, now let us again read one statement that if a simple pendulum has significant amplitude, that is up to a factor of 1 by e of original only in the time period between 0 to tau seconds. Okay, now that means this amplitude theta naught in a time interval of tau becomes theta naught by e, that is 1 by e of the maximum amplitude. So theta naught by e is equal to theta naught e to the power minus b by 2 times t, wherein this t is equal to tau. Okay, so this theta will cancel out and we will have e minus 1 equal to e minus b by 2 tau, where t is the tau or average time. That means b by 2 tau is equal to 1 or tau is equal to 2 by b. Okay, so this is the average life time.